The most prominent feature of this board is the unique space shuttle-like M.2 heatsink setup. It flips open like a butterfly, which is really neat, but there's kind of a performance benefit to this thing also. Welcome to Machines and More. So, board review today. This one is Asus's Strix Z890-I, which is a high-end enthusiast targeted ITX board for Intel's Core Ultra 2 series CPUs, and the Z890 chipset will allow manual overclocking for K-SKU CPUs. In ITX form factor, and for this particular chipset, Gigabyte, ASRock, and MSI also have representation. I haven't reviewed those yet. Hopefully we'll check out some of those in the future. The primary reason being I have found the Intel Arrow Lake CPUs to be a little bit mixed for recommendation. So they are worse than previous gen Intel gaming performance, paired with very good and excellent multi-core performance, so better efficiency than 14th gen. The 7 level 265K and especially the 5 level 245K CPUs can make sense for some builds depending on your price point. You might be happy pairing those with the B860 chipset. But alongside the Z890 chipset conversation is the top end 9 level 285K, and that one is a tougher recommendation because it's priced similarly to AMD's 9950X. It's quite competitive against that CPU in the production department, but the 9950X is generally going to be better for gaming. So that's the odd backdrop here. Real quick, Asus sent the board sample by for my review. Big thanks to them. They are not a sponsor for this video though, and you can trust my feedback because I will always give you an honest and personal opinion on this channel. So please support that. Make sure you are subscribed. All right, quick rundown on the board. There's a robust power delivery setup here. Total of 14 power stages. 10 are dedicated V-core stages at 110 amps each. 2 are 90 amps each for the VCCSA, which is the system agent voltage. And then another 90 amp and 80 amp stage. Paired with this robust power delivery is a thick heatsink section on the top and the I/O section. It's a very big, heavy board. There's a protective back shield. The board cooling is not passive though, so you do have 2 mini fans, which I know some users really dislike this type of board mini fan. You do have one fan here for, this is called a VRM fan, this is called the chipset fan. Good news is they are completely configurable in BIOS, and if you've run your system a while and you've figured out how your temps are, you can absolutely dial those down without temps getting out of control because of how good the power delivery setup is here. The butterfly style M.2 heatsink, right? This guy is very, very different than what you've seen on other ITX boards. Typically in your multi-drive setup, you're going to have one drive stacked on top of the other. Call it the multi-story drive, which is more difficult to get to the bottom drive, or you may have single one on the top with a more low-profile heatsink like the Strix B860i, and then you have one on the back that won't have built-in cooling, and that'll tend to be in a less than ideal airflow environment, especially in a sandwich style case. So sort of they have this intent to make it easier to remove and swap drives while enhancing the cooling capability. The mini chipset fan, which is positioned at the end of the ensemble under the shroud, will also encourage airflow through that heatsink section. So to remove the ensemble, you first loosen this thumb screw here, and you can remove this mini fan bracket, which I suspect most of you won't be using anyway. This is for optionally installing a mini fan to further have more airflow here. You just open this flap, and there's a screw here. I've already unscrewed this one, so you just kind of pull this out after that. The drives will install label side down, so you'll see the bottom side of the drive facing out, and that's going to be sandwiched in between 2 thermal pads. So the cooling setup is quite good. Both slots are Gen 5 compatible, although one thing to note, the one closer to the CPU socket does share bandwidth with the main expansion slot. So when a drive is installed there, you will still get Gen 5 speeds on both M.2s, but the expansion slot will go from X16 to X8. So it's not going to be a big deal for Gen 5 GPUs, since Gen 5 by 8 is like Gen 4 by 16, and most Gen 5 GPUs right now don't need a Gen 5. But if you have a Gen 4 GPU, like a 4090, this will be a small consideration since that will run at Gen 4 by 8. And then there will be a small but still measurable performance hit that way. If you are manually limiting the expansion slot, then there's also consideration because then you're going to downgrade the speed that's shared with that drive. So a couple things in play here. On the expansion slot, this features Q-Release Slim. So I understand this has been the subject of discussion lately due to the potential for scratching the card contacts, but ultimately I do like this feature. The correct way to unlatch a card is to tip towards the RAM side of the board and then lift the card out. But there are some design limitations with cases, not all of them accommodate this, notably where the expansion card's fingers seat. You do have to be careful not to pull it straight up and out because not all cases can allow that to tip inwards. So it won't necessarily hurt. It's just that if there is debris in the slot or whatever, it can scratch the contacts and wear them out. But this is more of a concern if you're a reviewer like me and you swap cards very frequently. Otherwise, I think in an ITX build, the value added is more that the latch location is not always easily accessible for that once every now and then removal and reinstallation, right? So let's take a look at the rear I/O. Lots of good stuff. 2 Thunderbolt 4 40 gig C ports that are also suitable for DisplayPort 2.1. You still get another USB-C port at 20 gigs, although I will footnote that if you plan on using the HIVE device, which I'll talk about shortly, this is where you'll connect it. 3 10G-A ports, 1 5G-A port, and 2 USB 2A ports. 2.5G-E, Wi-Fi 7 with Asus's quick release Q antenna. It's got a BIOS flashback button, which will work in conjunction with the port that's labeled BIOS. One very disappointing thing here is that there's no clear CMOS button. That is actually present on their B860i board, and that's an odd omission because it's more frequently needed for the enthusiast level of product for clearing settings if you're experimenting with an OC, that kind of thing. Top of the board, USB-C header, 20G, and then a 5G connector over here. So they are fitting a lot of stuff in this form factor. One thing Asus has been doing with their higher end boards recently is the add-on card. This board uses one of those. Without it, you only have a power button header. The add-on card gives you your 2 USB 2 headers, the full suite of front panel connectors, your clear CMOS, 2 SATA data headers. One neat feature that is a little bit more useful with the Gen 5 GPUs coming out now is this PCI alteration mode button. So if you have to downgrade your expansion slot since you're using a Gen 3 or Gen 4 riser cable, you don't have to do it in BIOS. You just take one step down from auto, set it in Gen 4, or all the way over what sets it in Gen 3. So while this FPS-II card is not super ideal due to the location of your cables potentially getting in the way, it is still adding a lot of functionality to the board. You can see it's quite tall. It's almost level with where the RAM kit is. So actually it's taller than it. 2 DDR5 slots. There is an LED that will illuminate if your RAM isn't installed properly. It's not a full-blown debug LED. It just illuminates that post as a status indicator as well. You get 4 full fan headers for this board, which is great. Typically, Asus mini-ITX boards have fan and RGB headers laid out at the top. This one is a little bit different. So you do have 3 fan headers here at the top. But then the ARGB headers, you get 2 of those over here, and an extra fan header. This is the 4th fan header. These are on a mini riser assembly. This is called a 2F card. This sits underneath the M.2 assembly. And when I tested this one with top-down cooler, I actually found this a very good location to plug in the cooler fan. You do have to change the indexing source because otherwise it's going to index your DIMM temperature. Just go ahead and tuck the cable underneath. It's very sleek. Last thing I'll note, board features no onboard audio. That is completely delegated out to this HIVE device, which does have quite a few functions. It's mainly an external audio solution with volume control, and it's also a USB hub since that 20G port bandwidth that you have to plug this into, it gets split out to 2 10G ports. So your debug LEDs are all at the front here. So you get a power button and an assignable flex key. So, you know, this, love it or hate it, it is what it is, right? So yeah, board sounds complicated because it is. I don't want to say there's a lot of moving parts because none of these things move, but there's a lot of things that are added onto this board to reach full functionality. And I think that's something that to be mindful of. It's kind of like a horse that was designed by committee. All right. I tested this board with a 285K and 245K. The board setup, mostly fine, no issues. What I will note is that while the M.2 heatsink, it's more or less level with the rear IO heatsink side over here, you will still see some incompatibility with small top-down coolers. So for example, I tested with ID Cooling's IS67XT. I did note in one particular orientation, the big thumb screw that sits above this heatsink assembly caused interference. So I do think it's a little bit of an oversight that it protrudes so much. There's not a huge value in making this thing toolless if you still need a screwdriver to remove this thing, right? So that's one thing. But thankfully with Intel's square mounting holes, you can just rotate and test fit some other orientations. Ultimately, I could get it to work in a side heat pipe orientation, but as a further counterpoint, coolers like Noctua L12S and L12 Ghost are listed as incompatible. And that is also the case with a board like Asus's own X890-ITX for AM5 CPUs, unfortunately. Asus's BIOS for the board is nice, high resolution. There's a whole bunch of fan control options, including both mini fans. There is a RAM timing tuning function that the board can do. It's called dim fit, and it does take a long time to run. 3 hours for me, but it can come up with some suggested parameters for your memory timing, so you can try that out. It doesn't hurt. You could just refer back to standard XMP for that, right? A few things to touch on in BIOS. With a K CPU, you do get to tune the CPU, kind of the point here. A few ways to do that. You can raise the core ratio limit. You can do that for all cores, or 1 core, 2 core, 3 core, etc. utilization scenarios. A quick way for cooling is good. You can just adjust the thermal velocity boost settings. The CPU does automatically lower its boost clocks based off of a table that's stipulated on how the cores are being utilized and the temp. You can ask to step up to a lower utilization boost target, for example, and that way you can get higher boost clocks for your all-core scenario, or you can also play with the voltage frequency offsets as well to further fine-tune or stabilize those adjustments. So you can also undervolt with power limits. So there's a lot to play with. This is going to be a lot more involved in overclocking on the Ryzen side nowadays, but it's also a lot more fun if you like optimizing things. Running this with a 285K on stock settings with a Noctua D15 Gen 2, I did get all-core P-core boosts in Blender render at 5.3 gigahertz, and that's mostly to spec, because typically you can get up to 5.4 if the chip is very cool. If I recall correctly, like 70 degrees. Here things did get a little bit warmer than that, although far from the max of 105. CPU was happily gobbling down 240 watts of package power here in that, you know, high 80s. So this boost behavior is typical. The E-core boosts are, whereas expected, 4.6 gigahertz across the board. So one of the things you can do in BIOS in the aforementioned thermal velocity boost is relax the thermal limits and say go up 1 bit on the table, you know, don't drop things down, even though if you hit temp. And I was able to get the 245K to 5.1 gigahertz on all performance cores, even with a small top-down core in the IS67 this way. So there's some value added with even with tuning at 245K, but we'll talk about the cost of that setup later. Throughout testing with the 285K board, and chipset temps stayed around 50 degrees, so they were never in any area of concern. So I think you can definitely tune the VRM and chipset fans to top out at, say, 50%, because just sitting next to it and playing with the fan curves on those, I could only hear them above 50%. They are absolutely annoying when they get close to max, but, you know, if you just max out there, I think it'll be fine. The main thing I wanted to test was what this does, and we have two competing scenarios, right? Because one is 2 drives stacked on top of each other, the multi-story setup, like in the X870i and other high-end boards. The other one is the one on front and one on the back of the board, which is more common with your B-level boards, like the BA60i. So first off, in the Fractal Terra, on the Strix 860, drive under the main heatsink with the X870i Gen 5 on the bottom position. It does get hot at 80 degrees and may see some performance impact at those levels, but the Gen 5 has to go there for Gen 5 speeds on that board. Here, however, the Z890i runs very cool. It does a very excellent job. As for a second drive, say a Gen 3 drive, since I really would hesitate to stick a Gen 4 drive on the back of the board type of scenario, it does end up pretty warm on the BA60i. The top slot of the dual stack multi-story on the X870i does tend to be good. If we look at the Z890i, it's going to treat both drives fairly similarly, and temps are still pretty good. So the two drive stack on top and bottom, that tends to treat one drive well and the other one bad. Same with the split back and top setup. So the value added here really is more that it splits the difference and results in temps that are both quite good for both, rather than, two extremes. As for the serviceable or convenience factor of this thing, I'm actually not quite convinced, because, yeah, if it's a liquid-cooled setup, you can easily remove it. If you have a cooler, like a top-down cooler covering the heatsink, as is common with some ITX setups, this isn't any different than a tall drive setup, the two-story setup. To get it off, you're still going to have to remove the heatsink, remove some components, and while that multi-story setup is slightly more involved to remove, I didn't feel like I was saving that much more time with this butterfly mechanism. So while the airflow to the drives is great in this setup, my take on that ease of drive swapping is that this is just a different way to do it versus a game changer. And if you're swapping off the top drive in that two-story setup, that actually might be faster than having to take this whole thing out and open it all up. So performance-wise, it's a very good board overall. I do like the M.2 cooling here. It is a pretty complicated board, though, and there's a lot of pieces that kind of go together to make it fully functional. So even though I do personally like it, that doesn't mean I would recommend it for most users. I do think there's a fairly narrow set of circumstances in which the user will get value out of this one. So first off, you have to want to overclock or manually tune your CPU. If not, I would handily go for the Strix BA60i, which is not as strong a power delivery, but still very capable. You can definitely run at 285K with this, and you can still OC your RAM. You still have the clear CMOS switch that doesn't have, and still very strong rear I/O. Avoids the complexity from the extra components that are needed to get onto the Z890i. But here's the conundrum. The 285K is pushed pretty far already, and you're generally going to get more added performance to OC 245K or 265K. But that brings us to the second point, because this is a very expensive board. At MSRP, it's more than twice of the Strix BA60i. It's similar in pricing to the Strix X870i. Right now it is on sale for $420 at US retailers. Not sure how long that'll last, but either way, it's still very pricey, right? You get a lot of features like the high-end power delivery and board cooling, which is tailored to a high-powered CPU. So realistically, the value makes the most sense if you're pairing with the highest end CPU, which is 285K, and you want a 285K if you had the option of the 9950X or 9950X 3D. Also, not saying that you can't, it's just that if you are getting this Z board to overclock to 45K or 265K, it might be a little bit odd value-wise, right? Because I would just, take that money and step up a CPU level and stick with a BA60, for example, right? There's also a Gigabyte Z890i that is a little bit weaker on I/O, but that's a lot more budget friendly. So strictly for production, if you can get 285K at a good price at a sale, then yeah, 285K, absolutely very good for that purpose, and pair it with this board. Third, you're going to need to want high-speed ports and run high-speed Gen 5 drives. For a high-end ITX production powerhouse that needs fast I/O, oh yeah. 2 Thunderbolt 4 ports is huge. You got 2 Gen 5 drives, all good there, right? By comparison, MSI's Z890i also has the 2 Thunderbolt ports, and while it can support up to 4 M.2s with the big riser card installed, only one of those is Gen 5 compatible. Fourth, and further narrowing the audience here, if you need this, the external audio solution. So I've said this before for other Asus boards reviews that require this HIVE. You can get value out of this thing since a decent external DAC and amp will run at least $100. And this is a pretty good one, but if you don't need one, or if you have one already, the cost cannot be decoupled from the board. And this component elevates the cost of Asus's board over something else like MSI's Z890-I, which is $370. The HIVE houses your debug LEDs, so you can't just say like, oh, discount this and not use it at all, right? So this is the sort of area that if you don't have a DAC, it could be great. Otherwise, you're spending a lot of money over another Z890i option. So, and that's a very narrow set of criteria, that narrows the audience for what is a decent, albeit high-end priced board. Most users, even for a 285K, I would steer towards the B860i, since this board, it just offers so much for the price. The user experience is a little bit more streamlined there. The Strix Z890i is tons of fun, really well built, heavy, overbuilt board. But you do want to know what you're doing to appreciate the features. So if you have any additional questions on something I haven't covered, please let me know in the comments down below. Please give a like. Make sure to subscribe. Check out the links for the setup. Big thanks for watching.